Hello, I'm Matthias, and in this short series of videos we're going to introduce Python, learn a little bit about the overall structure of the language, and this whole course is designed to be in conjunction with an online or offline meetup workshop that will be afterwards. So this is just to get you started, and I thought we begin with having a quick overview over Python itself. We're here on the python.org webpage, and you're welcome to browse through it. Especially the documentation has nice guides, especially also for beginners, to get your bearings a little bit on the language. So Python itself is a programming language. It's an interpreted language. We'll get back to that. And what you find on Python, if you, for example, go to downloads, you can download the Python source code. It's free, open source. So anything we will do is open source and open access. The problem is it's only this what you can get here is only the core language code. Python is very powerful and has a lot of additional modules built on top of it, which extend the capabilities of the language quite a lot. So I'll introduce briefly a couple of those, and just the ones that we're working with the most. First of all, there is Project Jupyter. So Jupyter from Julia, Python and R is a kind of language agnostic tool set to interact interactively with languages, programming languages or scripting languages, interpreted scripting languages in particular. We'll go over it in the next video on more detail how to set this up, just to let you know where it's coming from. The next heavily influential package, I would think, for science especially, is Matplotlib. It's a plotting library with basically capabilities for publication ready plotting, which is great because that's what in science most of the time what we want to have, right? If you want to produce your paper, you do your analysis on your software for your data, and then in the end you want to have a nice plot to put in your dissertation, your thesis, or your paper. That's what Matplotlib is for. There's a great there's a great example page where you can find lots of examples on how to with code. Everything is included with the code. I will go over this later. Okay, the next one I wanted to introduce is NumPy, Numerical Python. So the fundamental package for scientific computing with Python. Quite a powerful tool, especially if you're looking for larger data sets and how to interact efficiently with these data sets. Obviously, in Earth system science in general, we're interested also in plotting data onto maps, and I can recommend the Cartopy library, where you can just basically extend the capabilities of Matplotlib by mapping and projections. If you're going into more satellite or model data, like large data sets, and you need n-dimensional arrays, netcdf files, and so on, xarray is the way to go. We'll briefly afterwards also talk into xarray, have a look into xarray and how this works. Okay, for now have fun exploring the videos, try to get along a little bit, to type along and try things out yourself. If you have questions during the workshop, obviously I will be available. There will also be a set of additional exercises published along with these little videos, and I highly recommend that you follow through with them, that we can in the end clear up any issues that might have come up. See you soon.